Okay, so we're going to now continue to do our lesson, our flipped lesson, and we're going to talk this time about fractions and decimals, going between fractions to decimals and decimals to fractions. Okay, what we're basically doing is we're converting, and converting means to change. We're changing a fraction into the form of a decimal, or we're going to change the decimal into the form of a fraction. Well, a couple things we need to remember is that rational numbers are numbers that can be written as a ratio, basically. Remember that word ratio is right in the word rational. So just think about them as basically rational numbers are any number that can be written as a fraction or ratio, a over b, where b is not 0. Okay, so first we're going to talk about fraction to decimal. And one example of that would be 3 over 4. Now, you have to remember that 3 over 4 can be written as 3 divided by 4. Remember that division sign came right from the fraction form. We talked about that in class, that almost looks like a fraction right there, that division sign. And that's what it actually means. Okay. So now let's try 0.75, because if you take 3/4 and divide 3 into 4, you get 0.75, and that ends. Let me just illustrate that very quickly. When you have 3/4, you take the top number, and I like to say the top dog goes in the house. So you have 3, that number goes into the houses, so like a little house or division sign there, or division bar thing there, divided by 4. Well, 4 won't go into 3 evenly at all, so we need to put a decimal there and a 0 or 2. We bring our decimal up. 4 will now go into 30. It'll go into 30 7 times, and that'll be 28. Subtract that, leaves a 2. Bring down the next 0, and 4 goes into that 5 times. And that's how you get 0.75 from 3/4. All right, well, 0.75, it ends, right? There's nothing after that. We're done. We're finished. So we call those kind of numbers terminating decimals, because it ends. Terminate means to end. Other examples, we have 1/2. So again, the top number goes in the house, divide it by 2, put down your decimal, add a 0, put a 0 or 2 there, and it ends at 0.5. 3/5, we see that ends at 0.6. 1/20 might be a little bit interesting to you. Put the 1 in the house, put 20 on the side. Well, 20 doesn't go into 1. We put a decimal there, put a 0 there, it won't even go into 10. So remember, once you have the decimal, you have to have something in every place after that decimal. So because it won't go in there at all, we put a 0. But it will go into 100 5 times. So 1/20 equals 0.05. Then we have 1/8, which is another interesting fraction. Here we have the 1 goes in the house. We have to put 3 zeros there before we're done. We have 1, it goes into 10 one time, and then it goes into, you have the 2, then 20, goes into there twice, and then have to bring down another 0 before we can say that we're done. And that's so 1/8 equals 0.125. So some of them end after 1 decimal place, some of them end after 3, 2, 5, 8, but the fact is that it ends. And so we call those terminating. Okay. All right, now let's look at some examples that turn out a little differently. For example, 1/3. Well, we put our top dog goes in the house and divide it by 3. Put our decimal, couple of zeros, and we never finish. Look at this. 3 goes into 10 3 times. 9. 3 times 3 is 9. 1 left over. Bring down the 0. 3 goes into 3. 3 goes into 10 3 times. 9. 1 left over. We keep going on and on and on. There's no end. Well, so what do you notice? We notice that it never ends, but we also notice that it repeats. 3, 3, 3, 3, 3, 3, 3. It's never going to not be 3. Okay, it'll always keep on being 3. So, to show these two things, we use a bar notation. In the bar, you put the bar over the part of the numbers that repeat. So I could put over 33, because you could say 33 repeats, or you could just say, well, 3 repeats. Either one, it means the same thing, represents the same number. So we call those never ending, when it's never ending, we call it non-terminating. It doesn't end. And we call it repeating. So usually we call one like this a non-terminating repeating decimal. Okay, and it still is a rational number, and it can be represented, of course, as a ratio, as a fraction. Okay, so we can represent, that's an R, we can represent, not sure what happened to it, every rational number as a fraction. Okay, so I'll just put a bunch of fractions, like even the number 6 can be represented as 6 over 1. So every number that you know of so far in your life can be represented as a fraction, a ratio. Even 8.5, we can go 2 times 8 is 16 plus 1 is 17, so that would equal, this would really equal 17 halves. It's still a fraction, every number. 6 and 1/10, same thing. Okay, well those fractions can be divided sort of into two different categories when it comes to decimals. We can represent the fractions as terminating decimals, and there's a couple of them, like 0.5, 6.1, they're all terminating, they all end. There's no, they end, they don't keep going. Or else we can represent them as non-terminating repeating. Okay, if they're not going to terminate, for it to be a fraction, it's going to keep repeating. Okay, so we have 8.12, the bar over 1, 2, so 1, 2, 1, 2 repeats. 0.6666, you probably know this number, that actually equals 2/3, and we'll see that later. 2 over 3 is what that equals. That's going to equal some number. We don't know what fraction. We're going to figure out, we're going to learn how to do that next time. And all these other ones, these are all non-terminating. They don't end because you got the bar, which means it keeps repeating, but they keep repeating. Okay? All right. Now, next we're going to change decimals to fractions. So we've learned how to take fractions to decimal, top dog goes in the house, and then it's either going to repeat or it's going to end. Now we're going to take decimals to fractions. Well, it's very simple, easier than even changing fractions to decimals. If you just remember how to read it. Now a lot of times we'll see this and you'll say, oh, that's 0.6. Well, it is 0.6, okay, but you don't want to remember it as 0.6 because it's not going to help us get a fraction out of it. But you want to say, oh, that's 6/10. Remember the place values. Remember when you have your decimal, remember this is the ones place, that's tens, hundreds. Well, after the decimal, it's tenth, that's the 10th place, right? 10th place, that's the 100th place, that's the 1000th place, okay? The TH at the end. All right, so that's 6/10. All right, well, once you say, because you just said the fraction 6/10. All right, that's why you want to make sure you say it that way. And so all you have to do is write that down. 6/10, this 0.6 looks like 6/10. Now, in the case of 6/10, you can reduce it by dividing by 2, both the top and the bottom, not numerator and denominator, by 2, and you get 3/5. That's 5. Okay, so 3/5, that's 6/10, 0.6, if you want to say 0.6, that 6/10 really reduces to 3/5, really can be represented as 3/5 as a fraction. Let's do a couple more. All right, so we have 0.5, and you know 0.5, again, see I just said 0.5. That doesn't help you to figure out what fraction it is. If I say 5/10, that's 5 over 10, 5 divided by 10, and that reduces to 1/2. 0.05, okay, again, I said it in a way that wasn't very helpful. That's really 5/100ths, and that's 5 over 100. Well, if I divide both those by 5, I get 1 over 20. 0.16. Okay, I said it wrong again, but the right way to say it would be 16/100ths. Oh, there's my fraction, 16 over 100. Well, I know I can divide by 2 because they're both even. Okay, even numbers end in 0, 2, 4, 6, or 8. Okay, so I divide by 2, that's 8 over 50. Ah, they're even again, so I can divide by 2 again and get 4 over 25. And now there's no common factor of both those. If you knew ahead of time, you could have just divided them both by 4 here, and you would have gotten that same answer. All right, 2 and 2/10. Said it right that time. So 2 and 2/10, well, the 2's fine, but the 2/10 can reduce to 1/5 by dividing by 2 again. All right, 50 and 27/100ths. Remember, that really says and. The decimal, you can say the word and for that. 50 and 27/100ths, and that's simply right there, 50 and 27/100ths. I can't reduce it. There's no common factor. Okay, you have the 5 in the thousandths place. And if you have to count tenths, hundredths, thousands, you do not say ones, tenths, hundreds. There's no ones place after the decimal. There's only one ones place. We talked about that before, and that's to the left of the decimal. So the first place is tenths, hundredths, thousandths. So this is 5/1000ths, and the common factor for those is 5. And when you divide both by 5, you get 1 over 200. Okay, hope that helps.